RAHN, your partner for excellence. Printing processes. Offset Part 3. You see here in this diagram a rather simplistic representation of an offset printing. Offset printing is a more modern and complex printing process than those previously reviewed. These machines can be as small as a desktop and as large as a building. The basic aim is to provide ink in a thin film to a litho plate, which also has applied a found solution. These products interact. The found solution, or water-based material, causes the non-image area to stay clean, and the ink coats the printing area. The process. Litho printing plates can be made quite quickly, and with the latest CTP plates they can be made almost instantaneously in a digital form on a printing press. The plates are basically low cost compared to some other systems. The film thickness of the ink is approximately 1 micron per ink. It is a relatively high speed process, and UV has achieved speeds of as much as 450 meters per minute, though some oil-based conventional systems have reached speeds of 1000 meters per minute. It has very high quality. It is an indirect printing process. The plate is offset onto a blanket, so it is a planar, flat printing surface. And the print cylinder has a water film or found solution which allows the non-image area to stay clean. Application. Many diverse applications. Brochures, packaging, overprint varnishes, business forms, newspapers, advertisements, publicity, and many other areas. The ink is generally a very high viscosity, up to 200 Pascal seconds. Litho inks have a unique measurement called tack, and also suffer more from misting, and these two elements will be described later. It has a relatively high pigment load required because of the low film thickness. As already mentioned, it has high speed. The ink requires water balance in many different forms with the ink and the found solution working together on the different types of litho presses. And finally, like all other systems, it requires adhesion. Here we see a more detailed diagram of a lithographic press. And on the left hand side you can see numbered all the different components that play a part in the litho press. And when formulating inks, all of these elements of the press need consideration. The lithographic process employs a 4-color process system to achieve the final product. This basically is that the picture is broken down into the three major colors and a black. These are not primary colors. This is negative color as opposed to light primary colors, and they are cyan, yellow, magenta. Other systems do exist: hexachrome with 6, pentachrome with 5, and stochastic printing. These systems exist to achieve higher quality or a greater color range by only using 5 colors instead of many more to achieve the final product. Please note that the color gamut, or these 4 basic colors plus black that are used, are not the same throughout the world. In America and in Asia, they have slightly different cyans, yellows, magentas, and black. This is historical and geographical, and one has to formulate the right colors for whichever geographical area you may be selling to. As already mentioned, it's a very complex process, lithography, and the most difficult to assess and improve and determine is the lithography, or the water tests, or the litho tests. This in conjunction with the found solution, which in itself is a very complex mixture of chemicals and is a full technology in its own right. Both of these topics are further covered in the RAHN library if you should want to know more details on these topics. The first part of the ink, or the printing press, is the ink duct, where the ink is applied. UV curing inks generally have a higher rheology than oil-based inks, and most UV presses have duct agitators to assist in the flow. Formulation concerns will be to achieve the correct rheology profile for the press and the print quality, and these presses can vary in size, as already mentioned, and speed. Some of the larger, faster running presses have ink dispensers, and these require a totally different rheological profile than an ink duct. They have to flow, they have to be pumped. Equally true, if they have to be pumped or moved through pipes, then stability can be an issue, and often more stabilizers should be recommended to achieve this greater stability in the pumping of the ink to the press. We see here yet again an even more complex configuration. Web presses are usually bigger and faster and need yet again a different rheology profile and water balance. Web presses are more prevalent in the USA, where longer print runs lend to the economics. The USA is almost a one-language country, and some print runs can be in the millions of impressions. Tack and misting, as mentioned at the beginning, are 2 properties that are looked at in great detail for lithographic inks. Tack is the property of the stickiness of an ink, and is required for the inline printing of the 4-color process, where the printed ink must be followed by the second ink, which must not remove the first ink, and as you go through the process, each ink is accepted and continues to form the finished print. Tested on the same machine is also the misting. Misting, or flinging, is where, as the machine runs at high speed, it can create a mist around the machine of small ink particles. And one must be careful here that one chooses the correct monomer and oligomer selection to achieve the lowest mist properties. But it is usually solved also by the addition of fillers. The litho plate is also produced or developed by UV, and therefore the materials on the plate are UV cured and therefore sometimes very compatible or damaged with some of the aggressive monomers that may be used within a UV formulation. Some plates are not suitable for UV curing inks, and normally the printer will have to talk to his print manufacturer, and many print plate manufacturers have UV recommended plates. Cleaning materials for UV can damage the plate. So a further word on cleaning, which is often overlooked. UV curing inks do not clean up with traditional design cleanup solutions used for oil-based inks. They require solvents for cleaning, and these solvents can damage blankets or rollers or plate. Again, you can achieve solvent mixes which give good cleanup and minimize the possibility of damage to these elements. Also on the market, there are some solventless cleanup solutions. They work, but they are not as effective as the solvent-based systems. That completes the discussion of offset printing. Please now go to part 4 for a discussion on the flexo printing process. Thank you very much.